Okay, this is a problem in Nbhm question paper 2023. This is problem number 8. What it says that let A be a 4 cross 4 complex matrix with 4 distinct eigenvalues. Suppose that 0 is one of the eigenvalue. How many distinct square roots does A have? So, and they have defined a square root of a matrix A is any 4 cross 4 complex matrix such that B square is equal to A. Okay. So we will do this solution. First of all, we are given that A has 4 distinct eigenvalues. The moment we see that there are distinct eigenvalues, we get to know this that it is diagonalizable. So we can write A as A is equal to C inverse. This is a diagonal matrix into C gamma. This gamma is a diagonal matrix and C inverse gamma C. Okay. How does this gamma looks like? It looks like it's a diagonal 4 cross 4 matrix. So one diagonal entry is 0 and there is one lambda 1, lambda 2, lambda 3. Because we are given 0 is one of the eigenvalue, we don't know about lambda 1, lambda 2, lambda 3. They may be 0, they may not be, they haven't mentioned. Okay, now first I claim that every square root of A, that is, if there exists a B such that B square is equal to A, then B is of the form C inverse C. This is I am going to claim. Okay, first of all, see that this, if B is, we can easily see that if B is actually C inverse. Okay, wait, first we define what I mean by the square root of a matrix. Okay, sorry, the square root of gamma. This, okay. First of all, what do I mean by this is that because it's a diagonal matrix, we can just play it like just like real numbers, complex numbers. This is the advantage of the diagonal matrix, and maybe that's why they have given it's have 4 distinct eigenvalues, so it's diagonalizable. I mean is this. So gamma 1 by 2 is this, okay, and these are all zeros. Okay, first of all, if there is a B which is like this, then what happens if we take it square? This is equal to C inverse is equal to C inverse, these cancels out, and this is equal to A from here. From this, as we have taken A to be like this comes out to be A. So we have proved that if B is like this, then B square is equal to A. Now, if B square is equal to A, there is a matrix B such that B square is equal to A, then we know that every eigenvalue of B, every eigenvalue of B will be square root of A. We know from this Cayley-Hamilton theorem. We know that eigenvalues of polynomials are polynomials of the eigenvalue of the polynomial matrix is the polynomial of the eigenvalues. Of A, and also we know that when for polynomials eigenvectors remain same. Eigenvectors of A and B are same. Using this fact, we can write B as C inverse C. Okay, using the above two facts. So what we have claimed right now, that if there is a matrix B square, we satisfy B square is equal to A, then it has to be of this form: B is equal to C inverse gamma 1 by 2 C. Okay, C are here, these C's are here, the eigenvectors we know from diagonalizable. These matrices are eigenvector matrices, so they are fixed somehow. You can change eigenvectors, but accordingly they change. So B number of B's is only determined by the number of possibilities of these. Possibilities of gamma 1 by 2. Okay, now we again take what is gamma 1 by 2 we have defined. We have taken it as 0, lambda 1 की power 1 by 2, lambda 2 की power 1 by 2, lambda 3 की power 1 by 2, 0 elsewhere. So how many possibility does it have? It has two possibilities. This has two possibilities. This has two possibilities. So how many total possibilities we have? 2 into 2 into 2 is equal to 8. So there are 8 possibilities for this matrix, and thus there are 8 possibilities for B. Hence there are 8 8 matrices which can be square root of A. And there are two possibilities because we are in complex. These these are complex values, these lambda 1, lambda 2, and there are two possibilities. Hence there are 8 matrices which can be square root of A.